not sure why that's. I'm just not sure what that segment has to do with the radius, right?
It doesn't necessarily. I was just forming a shape to rotate it.
Yeah. So what you need to do is show that for any point, your radius is constant. So how do you do that? So if this represents any point, any and every point, right? Well, can you write any and every point? So can you write down coordinates for any and every point? And right. So then can you show that point? And then what do you want to show? You want to show that? It's what way all the way around?
It's that's the coordinate.
No, that's true. That's given. It's given that every coordinate on the circle has these coordinates. That's given. So what do we need to show that it's to make it show that it's a circle? What makes it a circle? Yeah, right. So how are we gonna do that? Okay, guys, you guys are gonna do it. Write a very, very good, clean proof here. All I'm gonna be is the pen. I'm not using my brain. So you guys write a good proof. What are we gonna do?
Given x equals cosine 2 pi t and y equals sine 2 pi t.
Okay, and what are you saying about that?
You know that radius squared, there's a formula, radius squared equals x squared plus y squared, right?
Are you declaring the equation of a circle? Is that when you say that? Okay, so I saw Sophia had her hand up.
So like given that x equals cosine 2 pi t, y equals sine 2 pi t.
Okay.
And since x represents the horizontal distance, and then y represents the corresponding vertical distance, you get a 90-degree angle that forms, and therefore you can apply the Pythagorean theorem.
Okay, so what's the first? Okay, yeah. So you're kind of giving the roadmap through the proof. Okay. So what's the first line? What are you gonna say? And what's the point of that? What is that? Why? No, but before even that, you're just stating you got x equals cosine 2 pi t, y equals sine 2 pi t. So what? What are those? What is that ordered pair? The whole circle. So this is the whole circle. Okay, yeah. Okay? So x equals cosine 2 pi t, y, which represents any point on the circle. Okay. Take it from there. What do you think? Kelly? You know what we do from there? Okay. So if we want to prove that this is a circle, where are we going with this? Jesus. Not sure. So what has to be true about any point on the circle if it's a circle? Or any point, I should say, any point on the curve, right? Any point on the given curve. Yeah, Jessica. Okay. Since every point on a circle is equidistant from the center, want to show what? WTS, want to show. What do I want to show? Okay, so we want to show that the distance from what to what?
0, 0 to cosine 2 by t, sine 2 by t is always the same.
Is, we can just say 1 because we're showing it.
Okay.
Right? So if, since every point in a circle equidistant from the center, we want to show that distance from 0, 0 to x, y above is 1. Okay? And so then, Sophia, you were talking about how to do that.
So like since the x represents the horizontal distance.
Uh-huh.
What?
Yeah, I said uh-huh. Mm-hmm.
X represents the horizontal distance, and then the y value in that coordinate represents the vertical distance that corresponds to that. You get a 90-degree angle.
Okay.
And if you were to draw a line from 0, 0 to x and y, you have a right triangle that is formed.
Okay.
And you can use the Pythagorean theorem to prove that that gives you a distance of 1.
So distance is c in the Pythagorean theorem, where a squared plus b squared equals c squared. Sorry. And so, d equals? Or c equals? Say. C equals what? C equals? Square root of? Squared plus b squared? C equals? Go, Brandon. Keep going. Okay. Equals? He wants it to be 1. Is it 1? It's 1. Therefore? It's a circle, right? So therefore it's a circle because of what we said. We wanted to show that the distance from 0, 0 to any point on the circle is constant, and it is. It's 1. Because that in here represents every and any point on the circle. No matter what t is, the same result happens. We get 1. Radius is constant, and the curve is a circle. If there's some type of form to proofs that they're teaching you that they always want, does this fit that form or not? You say yes. Is there anything your teachers wouldn't like about this proof? You can speak up.
Whenever I did proofs, I didn't really use the phrase "you want to show."
Okay.
But that just.
Yeah, so it kind of clarifies what you're doing, and then when you do that, then you can just say you're done by saying that. By saying you want to show this, and that will prove it, then when you do that, then it's kind of like, all right, We're done.
Other than that, looks
Okay, so you guys write out sentences and your proofs and okay. All right. Okay, questions on this example? Okay, so now I truly want to get a, whoa, wrong way. Now I really want kind of the ellipse that we were looking at if the scales were like this. How would I actually get the parametric equation for the ellipse? That we kind of were, our mind was telling us was an ellipse before. I want to actually get that ellipse. How would I change the parametric equation? What's that? Multiply by t on the outside. T cosine. It is not correct, but it might be fun. Yeah. Yeah, you can get some wild stuff. So, you have the right idea. How do we want to do this? Other ideas? Okay. You want to multiply cosine by 2, and then leave the sign as it is. So then all your, what will that say? Then all your x coordinates will be 2 times what they were before. Will it work? What do you think? Yeah. Yeah. So then you're just taking all your x coordinates and just, if they're positive, they're going to be twice as far out on the right side. If they're negative, twice as far out on the left side. So that gives us the stretch that we want. Okay. So part of the next homework assignment on this parametric stuff is going to be prove this is an ellipse. Prove this is an ellipse. Oh, the excitement just fills the room.
So is it not going to be a GC file then? It's going to be a proof?
The proof won't be a GC file. It's a worksheet, and you'll be working with GC, but then you'll be answering questions as well. Yeah. So it's part of that. So yeah, it'll be one of the questions will be prove it's an ellipse.
Can we just do like basically a different version of what we just did?
Except for really the premise of the circle proof was what? What was the kind of underlying thing with the circle?
That's equidistant, but
Yeah.
an ellipse isn't, so then you're just following that same pattern.
No, but it's not, right? So that's the whole point. You have different, every single point is a different distance. So you're not using the equidistant kind of idea in the ellipse proof. What's that?
You prove that it's
Not
not
a circle.
Well, that wouldn't prove that it's an ellipse, right? An ellipse is a very specific set of points, right? You could draw a zillion graphs that have points that aren't equidistant from the origin that would not be ellipses, right? Ellipses are very specific. Right, yeah.
Could be proven it's ellipse, like the same method we did with the, no, we couldn't probably, because that would require a radius to be,
Okay, so I love that you're thinking about it, but we don't have to solve it this minute, okay? So it's part of the homework. So I'm just giving you a preview. Yeah, Leo. Not very in depth, and that's why I just did an example.
Very.
Yeah, so that's why I just gave an example. So this is the last proof in the class now. Okay. So, and I gave you an example, and now you're going to do this one. Okay. So you'll be okay. Okay.
Don't act like you don't know proof.
Okay. Okay, so just so you know, so this what would be, so we're back here at this, showing this part of the circle. What would be another way to show the whole circle, right? So we took the argument and multiplied the argument to t by 2 pi, and that worked. What would be another way to show the whole circle? Yeah.
Change the range of t from 0 to 1 to 0 to 2 pi.
Yeah. So we could have just changed the range, and you could do that over here. Okay, and that would have the same effect. Okay. No. Oops. Oh, I gave it away. What happened? Darn. This is not going as planned. Okay, so. All right. So what I want to do is, I want to show both of these at once. So that's showing what angles there. The smile shows what angles. Yeah, so this is showing part of a circle, right? So this is showing the circle of radius 1.5, and this is showing part of a circle of radius 1. Okay, so get out GC. I want you to reproduce this. So I've got a circle of radius 1.5 and a circle of radius 1, and so I want to practice using parametric functions to do this. That's the circle of radius 1.1. Okay, exactly, right. So that's going to screw mine up. Okay, so here are those two parametric circles. Now, how do I get, so if I want to get the whole circle for the face, the outside, what can I do to get the whole circle? What's that? You want to include the 2 pi on the t? Is that what you mean? Or do the 0 to 2 pi? What's that? Doesn't really matter. Okay, so if I go from 0 to 2 pi here, I get the whole circles. Now, what if I want to show the smiley? If I just want to show the smile on the red one, that's kind of like the same change I just made, but just what I'm going to change it to. No. What does t represent, you guys? What does t represent when I say 0 to 2 pi? What is that representing then, now? But what quantity? What quantity is t taking on? If I make it go from 0 to 2 pi, cosine t, sine t. What kind of quantity is that taking on? It's an angle measure, right? Angle measure. So if I want to show just the smile, I could change t, right? To what? It's actually splitting it here. So I had it splitting here and splitting here. Yep, 5 pi over 4. To what? So 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4. 7 pi over 4. Okay, well, what's the problem? our full circle is gone, right? So now our full circle is gone. Do 2 pi t for the purple one. So now what's really happening? Is it really graphing that first one? Is it really graphing it from 0 to 2 pi? No, it's getting all the points, but kind of in a weird way, right? Because it's starting at this 5 pi over 4 number and going to 7 pi over 4, and then multiplying that, you know, that range by 2 pi. So that's working, but it's it's not very clean, right? It's not that now we're not really in control of how that first one's graphing. Yeah.
How do you do that in the Windows? Because I can see that in
In Windows, does it show up? Can you click on it and change it?
You just click on the number and then
Just click in there. Just get your cursor in there and click until the blink. Okay, so really to make this, we kind of want to have this in our control, right? So that we graphed all the points, but now that the purple one is kind of like outside our control, we took 2 pi times the range from 3 pi over 4 to, or 5 pi over 4 to 7 pi over 4, and so it's just kind of, we don't know where it's starting, right? We don't know where it's starting and where it's ending. It may be overlapping, right? So what our goal is here is, can we do it with t being from 0 to 1? Okay, so that's what I'm showing here. I'm showing both show up when t goes from 0 to 1. So as t goes from 0 to 1, I want the purple circle. What do I want to happen with the purple circle? 0 to 2 pi. Right, 1 rotation. But then the red circle, what do I want the red circle to do? So as t varies from 0 to 1, I want the purple angle on the circle to vary from 0 to 2 pi. As t varies from 0 to 1, I want the red to do what? Right. Ever learned anything like this before? As t goes from 0 to 1, we want some other thing to go from 0 to 2 pi. And then some other thing to go from 5 pi over 4 to 7 pi over 4. Sound familiar? Remember what this was? Well, okay, something like that. Let's figure it out. So what do we want? We want when t is 0, let's do it for this one. When t is 0, we want to get 5 pi over 4. Right? So we're going to have 5 pi over 4. And we're going to have 7 pi over 4 in there. And then when t is 1, we want it to be 7 pi over 4. So how would that work? When t is 0, I want to get 5 pi over 4. And I want the 7 pi over 4 to be wiped out. When t is 1, I want to get 7 pi over 4. And I want the 5 pi over 4 to be wiped out. Remember this? So how do I, when t is 0, I want to wipe out 7 pi over 4. And when t is 1, I want the 5 pi over 4 to get wiped out. So what would it be? Okay, so take your, stop working in GC and kind of bring your attention back to here when we're going to figure this out. If you don't remember something, then maybe we can figure it out, and then it'll stick better the next time. So eventually we will remember it and don't have to keep figuring it out. But what do we do with t's so that when t is 0, 7 pi over 4 goes away? It's very simple. Will that make 7 pi over 4 go away when t is 0? Yes. And what do we do with t so that 5 pi over 4 goes away when t equals 1? Okay, so which one? 1 minus t or t minus 1? Now think about numbers like we're going to have numbers like 0.2, 0.5, 0.7, 1 minus t. And one last thing to do. Plus. And so now the beauty of this is I can graph lots of parametric equations, and t is always going from 0 to 1. Because when I graph parametric equations, I always got to use t. And I can't make t 0 to 2 pi for this one and 5 pi over 4 to 7 pi over 4 for that one. So rather, in my command line, I can use this construct here for the angle as t changes from 0 to 1. Now that thing will give me the angles from 5 pi over 4 to 7 pi over 4. So what will it be for 0 to 2 pi? So I want to write that out for, say, if I want my angle to vary from 0 to 2 pi as t varies from 0 to 1, what would it be? What's that? 2 pi times t? Okay. That's it? Yeah. You're right, which goes away. You're right. So that's kind of what we came up with earlier, right? Just put in 2 pi t, and that was so easy because the starting value was 0, and that made it easy. So then when you start with something else, you're going to do the 1 minus t times 5 pi over 4. So the goal is keeping t 0 to 1, so we can have the smile, and then we can have eyes. So now, see if you can do it. So this is what? This is your angle measure. This is going to give you the range as t varies from 0 to 1. This is going to give you all the angles that you want for the red smile. So can we start using that construct to our advantage here so that we can do this? So see if you can come up with that. And then we'll do the tongue.
Hey, look.
Okay, so now we want to use this thing that I'm trying to teach you.
Right.
Instead of just,
Whoa.
because that's not centered at the origin. That's circle. So yeah, it's a beautiful smile, but it's not the mathematics we're doing. So what does this do? This gives all angle measures. So before that, let's get the smile first before the eyes. But this gives all angle measures from 5 pi over 4 to 7 pi over 4 as t goes from 0 to 1. So the point is that this equals angle measure. Specifically, in a parametric equation, this set of angle measures. But that thing, for a given value of t, it's going to give you an angle measure. If t is 0.3, it gives you 30% of the way. It gives you the angle measure that's 0.3 of the way from there to there. If t is 0.6, it gives you the angle measure that's 0.6 of the way, 60% of the way from start to the finish. So that thing in brackets is an angle measure. That's how you're going to construct your GC line to make this work. So does anybody have it?
I just
Got it?
had your equation. To show you like how I It's okay. I think if t is like a percentage, like if t is like at 0.1.
Okay, so now let's really put parametrics to work here. So any of these, we could have finagled by y as a function of x, right? The only thing we'd have to do is that the circle, the purple circle, we'd have to split it up into two functions, but all the rest of it is y as a function of x. So, boo boo. What about this? Can we write y as a function of x for the tongue?
Yeah. I've been doing that a lot.
Y is a function of x? Can you write y as a function of x for that thing?
No.
No, definitely not. Okay, but in terms of as a parametric, we can kind of figure out what's going on here to do it. So let me show you what's happening here. This is kind of based on a circle, that's bottom half of a circle, and this is the left side, kind of the left side of the circle, and then the right side is like here, because this is as far as it goes to the right. So it's kind of based on, and how far down does it go? It gets down to about here. Okay, so it's kind of based on this semicircle. But what's happening? How have I messed with it here? So what does the y coordinate do? The y coordinate of those points starts where and ends up where? So imagining this is a circle, right? So the y coordinate starts where and traverses through what part of the circle? Yeah, it doesn't just do the negative side, right? So y goes down to its lowest point, and then even though something's going on with x, it makes it back up to here. So really y, just what angle measure does y go through from here to here? From what to what? Pi to 2 pi. Do you see that the y coordinate goes from pi to 2 pi? Okay, so that's the clue. The clue is that your y goes from pi to 2 pi. And then if you can figure out what x does, then you can graph this. So now the center of this thing is 0.25 and like negative 0.95. So that's the center. That's the center, okay? That's the center of the circle. 0.25 and negative 0.95, right about there. And so I'm kind of graphing the lower half. So the y coordinate, we see the lower half as the angle changes from pi to 2 pi. Right? But can you trace what the x does? And if you can figure out what the x does, then you can reproduce that. So what does x do? So the y angle from pi to 2 pi. Anybody have an idea? What does the x angle start at? Yeah, it also starts at pi. Because it's talking about the left side of the circle, right?
My thought was that it would go to
3 pi over 2. So where is 3 pi over 2 on this circle here? So as we traverse this curve, x just goes from pi to there. Is that what it does? That's where it ends up. But that's not the journey that it makes. What's the journey that it makes, right? What does the x value do? Do you see that x goes, does it make it to 2 pi? Does x make it to 2 pi?
Yeah.
And then what?
And then
How far past?
a little bit.
No, where does it end up? You know exactly how far past it goes. It makes it back to the center. So y's journey is down to the bottom and back up. That's pi to 2 pi. X's journey is simultaneously x's journey is out to the right and then back to the middle. So that would be pi to what? What's that? Right. So it's gonna go to 2 pi when it's reaching 2 pi here, right? The x coordinate reaches 2 pi here. Okay, now you're on the right track. So if it was 3 pi, it would make it all the way back to here, right? If it went pi to 3 pi, it'd make it all the way back to the starting point. Right. So as y goes from pi to 2 pi, x goes to 2 pi, and then also another quarter circle plus pi over 2 more. So what is that? 9 pi over 2? No. 5 pi over 2. So x goes from pi to 5 pi over 2. All right. The radius is 0.5. And the center is 0.25, negative 0.95. So you got to put all that together. Your angle, and you've got to use this construct from 0 to 1, right? So as t goes from 0 to 1, we want the y angle to go from pi to 2 pi. We want the x angle to go from pi to 5 pi over 2. And we want the radius of 0.5 and a center of 0.25, negative 0.5. So that's for you to work on. So you can go to your friends who can't get it.